Hello class, let's learn about redox reactions and molarity. Oxidation numbers are a useful way to keep track of electrons in a redox reaction. These are the set of rules that we follow to assign oxidation numbers. Rule number 1. Substances in their elemental state have an oxidation number equal to 0. Monoatomic ions have an oxidation number that's equal to their actual charge. For many covalent compounds, following oxidation numbers are used in decreasing priority. Fluorine -1, hydrogen +1, oxygen -2, and other halogens -1. Rule number 4. The sum of the oxidation numbers must equal to the overall charge of the compound. Let's do some examples. Let's take X as the oxidation number of phosphorus. According to rule 3D, chlorine has -1 oxidation number and the overall charge of this compound is 0. And you see that phosphorus has a +3 oxidation number. Let's take X as the oxidation number of oxygen. According to rule 3A, fluorine has -1 and we have 2 fluorines. That means we are going to multiply this -1 by 2 and the overall charge of the compound is 0. So the oxidation number of oxygen in this compound is +2. Sulfate. Let's take the oxidation number of sulfur as X. And according to rule 3C, it says oxygen has -2 oxidation number. So we have 4 oxygen atoms. So we are going to multiply -2 by 4. And the overall charge of the compound is -2. That makes the oxidation number of sulfur to be +6. Oxygen. So rule number 1 says substances in their elemental state have an oxidation number of 0. So oxygen has oxidation number of 0. Same goes to phosphorus. So this is the elemental state of phosphorus. According to rule number 1, it has oxidation number of 0. Sodium. When sodium in its solid elemental state, according to rule number 1, it has oxidation number of 0. Same goes to chlorine. When something is in elemental state, they have an 0 oxidation number. Let's do few more examples. Let's take X as the oxidation number of aluminum, and we know fluorine has -1 oxidation number, it has 3 atoms, and then the overall charge of the compound is 0. So the oxidation number of aluminum is +3. Oxygen has -2 oxidation number, we have 2 oxygen atoms, and the overall charge of the compound is 0. So the oxidation number of nitrogen is +4. Again, oxygen has -2 oxidation number and the overall charge of the compound is -1. In this case, the oxidation number of nitrogen is +3. Oxygen has -2 oxidation number again, and then we have 3 atoms and the overall charge is -1. The oxidation number of iodine is +5. Sodium has +1 oxidation number and we have 3 sodium atoms, and let's take X as the phosphorus oxidation number. Oxygen has -2 oxidation number and the overall charge of this compound is 0. So the oxidation number of phosphorus is +5. So let's find the oxidation number of carbon. We have 6 carbon atoms. That means we are going to write it down as 6s. Hydrogen has +1 and we have 12 of them. Oxygen has -2 and we have 6 of them. And the overall charge is 0. That makes the oxidation number of carbon is 0 in this compound. Let's look at following redox reaction. Redox reactions are the reactions that involve a transfer of electrons between reactants. Let's look at copper first. Copper in elemental state has 0 oxidation number and copper 2 plus has 2 plus oxidation number. That means copper lost 2 electrons. Loss of electrons means it underwent oxidation. So you can remember these two phrases. Oxidation is loss, reduction is gain. Nitrate to nitrogen dioxide. Nitrogen in the nitrate has +5 oxidation number. Nitrogen in nitrogen dioxide has +4 oxidation number. +5 to +4, that means it gained 1 electron. Reduction is gain, that means nitrate underwent reduction. Let's look at this redox reaction. Let's find out the oxidation numbers first. Zinc and iron are in their elemental states and they have 0 oxidation numbers. Iron has +2 oxidation number, zinc has +2 oxidation number. Ferrous chloride turns to iron. +2 to 0 means gain of electrons, means reduction. Zinc to zinc chloride 0 to 2 plus means loss of electrons, means oxidation. We call ferrous chloride an oxidizing agent and zinc a reducing agent because the oxidizing agent is the reactant that is oxidizing another substance. In this case, it oxidizes zinc. A reducing agent is the reactant that's reducing another substance. In this case, zinc is reducing ferrous chloride. Methane reacts with oxygen and produces carbon dioxide and water. First, you have to find out the oxidation numbers. Oxygen is in its elemental state and it has 0 oxidation number. Carbon in methane has -4 oxidation number. Carbon in carbon dioxide has +4 oxidation number. Oxygen in water has -2 oxidation number. So in here methane goes to carbon dioxide -4 to +4. That means loss of electrons means oxidation. That means it is a reducing agent. Oxygen goes to water 0 to -2 means gaining of electrons means reduction. That means oxygen is a oxidizing agent. Now let's talk about molarity. Molarity is a way to express the concentration of a solution. To find the molarity of a solution, you need to find the number of moles of the solute in a liter of solution. Let's do this example. Find the concentration of a 200 milliliters of a solution that contains 4 grams of sodium hydroxide. So we have given the mass of sodium hydroxide and volume in milliliters. So we need to convert this much of grams into moles. For that we are going to use the molar mass of sodium hydroxide. And we need to convert milliliters to liters. For that we are going to use the relationship between milliliters and liters. Let's start with 4 grams, and we know the molar mass is 40, and we are going to use that information in a fraction in such a way that grams to sodium hydroxide cancels to grams to sodium hydroxide. Now we have 0.1 moles of sodium hydroxide. Next, we are going to convert the milliliters to liters. We know 1000 milliliters equal to 1 liter. So we have 0.2 liters. Now we are going to find the molarity, number of moles divided by the volume in liters. So the molarity of this solution is 0.50 moles per liter. You wish to make a 4 liter of a 2 molar potassium bromide solution. How many grams of potassium bromide are required? Now we know the molarity equals to number of moles of solute over the volume in liters. When you say a 2 molar solution, that means you have 2 moles dissolved in 1 liter. In this case, 1 liter of potassium bromide has 2 moles. Also, we are going to use the molar mass. 1 mole of KBr weighs 119 grams. So let's do a dimensional analysis and start with 4 liters. We know 1 liter of KBr has 2 moles of KBr. So in this fraction, we are going to find out the required number of moles of potassium bromide to make this solution. And we are going to convert this moles to mass now. We know 1 mole of KBr weighs 119 grams. You can see the units cancel out and you are going to end up with grams of KBr. So you need 952 grams of KBr to dissolve in 4 liters of water to make a 2m KBr solution. Calculate the mass of solute required to make 1 liter of 5m sulfuric solution. When you say 5m or 5 molar solution, that means you have 5 moles in 1 liter. In this case, 1 liter should have 5 moles of sulfuric acid. Also, we know by molar mass, 1 mole of sulfuric weighs 98.079 grams. So we start with 1 liter of sulfuric and going to find out how many moles are required to make a 5m solution. So we know 1 liter of sulfuric should have 5 moles of sulfuric. You see the liter sulfuric to liter sulfuric cancels out, and then we have the number of moles of sulfuric. Then we are going to convert it to mass. For that, we are going to use the molar mass. So you are going to need 490.4 grams of sulfuric to make 1 liter of 5m sulfuric solution. Let's do a dilution question. Nitric acid is usually purchased as 60 molar stock solution. If you wanted to make 800 milliliters of 0.50 mole nitric acid, how many milliliters of stock solution would be required? For this, we are going to use this equation, and we take M1V1 as the molarity and volume in one condition and M2V2 as the molarity and volume in the other condition. So here let's take M1 and V1 as the solution we are going to make. M1 equals 0.05 m, V1 equals 800 milliliters. M2 equals 16 m, that means this is our stock solution, and the volume is the one we are going to find out. So by this equation, we know V2 equals M1 V1 over M2. So we are going to plug in our numbers and we are going to get 25 ml as the answer. So we are going to take 25 ml of the stock solution and Dilute it to 800 milliliters.